Welcome back, Algebra 1. We are going to start talking today about solving and the solutions to a quadratic function, which remember solutions, if you remember from the last video, solutions are the same as x-intercepts. They're the same as roots, same as zeros. And we're going to get into one method of solving. So last video, we talked about solving by graphing, and that was just looking at the graph and finding where the graph crossed the x-axis. Today, we're going to start talking about how to do it algebraically. So the solutions to a quadratic function are the point or points at which the parabola crosses the x-axis. Also known as roots or zeros or x-intercepts. So in the last video, we talked about x-intercepts. Today, it's the same thing. And now we're just calling it solutions, which is probably the most common way that you're going to hear us talk about x-intercepts is when we say solutions. Now, something that you guys may have learned before, I can't remember if you've learned it like in prior years, but it's called the zero product property. The zero product property says, and what it's implying is if the product of two quantities equals 0, then at least one of the quantities will be equal to 0. For example, if I said something like x times y equals 0, well, that tells me that either x is going to be equal to 0 or y is going to be equal to 0 or both are going to be equal to 0. So either x equals 0, y equals 0, or both equals 0. Because the only way that we can multiply two numbers together and get 0 is that one of these has to be equal to 0. Now, using it in a kind of like more factored form, which is what we're going to be doing over here in this lesson today, is if x plus 3 times x plus 2 equals 0, then x plus 3 must be equal to 0, or x plus 2 must be equal to 0. Okay, so let's get into solving by factoring. That's going to be our first method to solving by factoring. Now, one thing that I'm going to mention, and it's probably not going to be super relevant right now because we're not seeing all the different methods, but we use solving by factoring when you can easily factor the quadratic. And so we use the factoring method first when we have either y equals ax squared plus bx, which we're going to talk about that one, or y equals ax squared plus bx plus c, and the quadratic is factorable. Now, right now, all we've seen are factorable quadratics. We're going to talk about later and maybe next week, what you would do if you couldn't factor this quadratic. But we're just going to be right now dealing with just quadratics that you can factor. Okay, so I have an example. I have the steps. We're just going to go through just like we normally would. just kind of walking you through how to solve this. So our first step when solving a quadratic by factoring is to move everything over to one side of the equation. So move everything over to one side of the equation. What's super, super important, and probably the most important thing here, is the equation must be equal to 0, and which is going to lead us into the zero product property. So equation must be equal to 0. If it's not, this method is not even something you could do. So you're always wanting the equation to be set equal to 0. Okay, so that's our first step. Is my equation set equal to 0? And it's not. So we need to start by just moving the 10 to the other side of the equation. And I'm going to do that by subtracting. And I get x squared plus 3x minus 10 equals 0. Okay, so that's my first step. I moved everything over to the one side of the equation. Everything must be equal to 0. It is. So now my second step is to factor the quadratic. So I am now thinking about what's two numbers that multiply together to get me negative 10 and add to get me positive 3. So I'm back into last section's material. And if factoring is something that you guys haven't really mastered, it's going to be crucial for this chapter. So I really encourage you guys to either go back and watch my video, go online and find some videos on Khan Academy. Khan Academy you could literally type in factoring trinomials and they will put they have multiple videos so you guys can watch those. So I really, really encourage you guys, if you don't know how to factor yet, please go back and watch those. Okay, so we're thinking what multiplies together to get me negative 10 and adds to get me positive 3. And that's 5 and negative 2. Now I can use my shortcut here. The reason I can use my shortcut here is because a is equal to 1. So I can factor it to be x plus 5, x minus 2 still equals 0. Okay, then once it's factored, now actually I'm going to write a little note. We can only use the shortcut because a equals 1. So after we've factored the quadratic, this is when the zero product property comes into play. Because x plus 5 times x minus 2 equals 0, that tells me one of the quantities or both of the quantities can be equal to 0. So what we're going to do is set each factor to 0. So when I set each factor to 0, I have x plus 5 equals 0 and x minus 2 equals 0. And so now that I've set x plus 5 is equal to 0 and x minus 2 equal to 0, so I separated them, my fourth step is to solve each factor separately for x. So solve for x for each factor. So all that means is I'm going to subtract 5 from both sides, and I get x equals -5. I'm going to add 2 to both sides, and I get x is equal to 2. And now I have my two x-intercepts. My last step is to write as ordered pairs. So in an x-intercept, and it's something that I probably should have said up here, so I'm going to come back to it a little bit. Your x-intercepts, the solution to a quadratic function are the points where the parabola crosses the x-axis. This is like we're basically solving for x when y equals 0. Just like before with our y-intercepts, we solved for y when x is equal to 0. So for like an ordered pair, you're always going to write it as x comma 0. The y will always be 0 in here because it's an x-intercept. So an x-intercept will always have a y value equal to 0. So when we write our solutions here, we have two different ones. So it tells me that it's going to cross at -5, 0, and then at 2, 0. And that is it. That's my solutions. Now, if I were to actually go on and graph this on Desmos, so if I were to type that equation in, so x squared plus 3x, I could even do equals 10. We're going to see that the parabola, which it's a super low parabola apparently. Holy Toledo. Actually, let's rewrite it like this. That will probably make the whole thing less weird. But when I graph and I look, okay, my two solutions are at 2 and at -5, which are the two that we found, 2 and -5. Okay, so let's go on to some examples. We're just going to kind of power through the examples here. So solve each quadratic by factoring. Write your answer as an ordered pair. First thing, I want to make sure, is my equation set equal to 0? And the answer for number 1 is yes, it is set equal to 0. So we move to the second one. We move to just factoring. So I'm thinking, what two numbers multiply together to get me 21 and add to get me -10? So think about those two numbers. What are my two numbers that multiply together to get me 21 and add to get me -10? And if you're thinking -7 and -3, you would be correct. And now we can go straight to the shortcut because a is equal to 1. So I'm going to factor x minus 7, x minus 3 equals 0. Now that it's fully factored and it's equal to 0, I can set each factor equal to 0. X minus 7 equals 0 and x minus 3 equals 0. And now I can just solve each of them for x separately. So x minus 7 equals 0. I'm just going to add 7 to get x by itself. And I get x is equal to 7. Then I'm going to add 3 to both sides. I get x is equal to 3. So that means my solutions, my x-intercepts, are going to be 7, 0, and 3, 0. And that's my answer. Okay, so what I want you guys to do is I want you guys to look at 2. I want you guys to try 2 on your own. So I really encourage you guys, pause me here and try 2 all by yourself and then come back and check to see, did you get the same answer as me? If not, where did you go wrong? If you did, great, move to the next one. Okay, so you should be coming back just to check your work. First step, is my equation set equal to 0? And it is. Second step is factoring. Now, I'm going to kind of go through this a little bit quicker because I'm hoping that you have been trying this one on your own. Now, if you need more of an explanation and you need more help, always come into office hours. But my next step now is going to be to factor. And just like that, all of a sudden, my quadratic is factored. Remember, we can use this shortcut here because a is equal to 1, so I can go straight into this like without splitting the middle term. Okay, now my second step is to set each factor equal to 0. And just like that, it's done. So I set each factor equal to 0, and now I'm going to solve for x for each factor. So that means I'm going to add 5 to both sides. I get x is equal to 5. Subtract 4 from both sides. And I get x is equal to negative 4. And then we just write those as ordered pairs. 5, 0. Negative 4, 0. That's my answer. Okay, so let's move on to the next set of problems. Okay, so we have number 3, x squared minus 5x minus 64 equals 7x. So our first step here is to make sure our equation is set equal to 0. And this one is not set equal to 0, so that's the first thing we want to do. We have the 7x on the right side, so I want to move it over. Be careful to see which one is it going to combine with. Is it going to combine with x squared? No, because it doesn't have a squared on it. Is it going to combine with negative 5x? Yes, these are my like terms. I have to put a piece of paper under this because it's going to drive me nuts if I don't. Okay, so then I can write my equation. So I have x squared minus 7 and 5 get me 12 minus 64 equals 0. Now that it's set equal to 0, now we can go ahead and factor. So we're thinking, what two numbers multiply together to get me negative 64 and add to get me negative 12? Now this one's a little bit trickier, but going through our factors, we know, okay, 16 times 4 gets me 64, so it's going to be negative 16 and positive 4. Can I use the shortcut here? Is a equal to 1? The answer is yes, a is equal to 1, so I can go straight to my shortcut. X minus 16 times x plus 4 equals 0. Now that it's fully factored, I can set each factor equal to 0 and then solve for x. So I first start by adding 16 to both sides of my equation, and I get x is equal to 16 as one of my solutions. I will go to the next one, subtract 4 from both sides, and I get x is equal to negative 4. Now, in the prior problems, we were writing these as ordered pairs. oftentimes you won't see them always written as ordered pairs. What you'll sometimes see is just x equals 16, x equals -4, or x equals 16, -4. Now, one thing that's really, really important, if you're not writing them as ordered pairs and you write it as x equals, do not put parentheses around that. If you were to put parentheses around it, you would be signifying that it's a point, 16, -4. And that point is not the solution. The solutions are 16, 0 and -4, 0. So when writing it as just x equal, do not put parentheses around your answers. Okay, so what I want you guys to do is try number 4 on your own. Go through 4, try as much of it as you can, and then come back, check your work. Okay, so you should have checked your work. First step is to think, what do I need to do so the equation is set equal to 0? And now that one is going to be moving the 21 over. The 21 can't combine with anything. X squared it can't combine with, 4x it can't combine with. So we're just going to write it as x squared plus 4x minus 21 equals 0. Now that everything is moved over to one side of the equation, now I'm going to factor. And it's factored. So now that it's completely factored, we can set each factor equal to 0. And then once everything's set equal to 0, we can solve for x. And we have our two solutions. So our two solutions are -7 and 3. That means my graph crosses the x-axis at both -7, 0 and 3, 0. Or we can just write it as x equals -7, 3. And that is your final answer. Okay, let's look at 5. First step, always the same. Is my equation set equal to 0? And it's not. I always, as like a thumb, like a rule of thumb, yeah, that's what it is. I always like to have the x squared be positive. So what I like to do, if the x squared is here and it's positive, I'm going to move the 15 or the -15x over to the other side. So I'm going to add 15x to both sides. So those can't combine. This has an x squared and this has an x. So those can't combine. It's 3x squared plus 15x equals 0. Now this is not your common like trinomial, right? We only have two terms. But hopefully you're seeing that those two terms have some things in common. 3 and 15, those numbers are both divisible by 3, and they both have an x squared, x, they both have an x that I can factor out. So I can actually factor out a GCF here. So I can factor out a 3x, and I'm left with x plus 5. 3x squared divided by 3x. 3 divided by 3 is 1. X squared divided by x is x. 15 divided by 3 is 5. X divided by x is 1. 5 times 1 is 5. Equals 0. So all I did here was factor by GCF. And now that it's fully factored, there's nothing more I can do with either one. I can set each factor equal to 0. Now what's really important is we set 3x equal to 0, and we set x plus 5 equal to 0. And now I can solve for x. So first I'm going to divide by 3 to solve for x because it's being multiplied. X is equal to 0 divided by 3 is just 0. Subtract 5 from both sides. And I get x is equal to -5. And I have my two solutions. 0 and -5. Now written as ordered pairs, the way that you would write these as ordered pairs because of that 0 This one would be 0, 0, which would be also the y-intercept, and negative 5, 0. Okay, so what I want you guys to do is pause me here for 6. I want you guys to try 6 on your own. See if you have any questions or need any help with that. Come back, check it, whatever you guys need. Yeah, so pause this one, try it on your own, see how you do. Good luck. Okay, so you should be coming back. Your first step for number 6, always, 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 is you want to make sure that the equation is set equal to 0. Okay, so all I did was I moved the 6x to the other side of the equation. Those couldn't combine, and so now it's set equal to 0. Next step, factor. Now this is not your normal trinomial, so I'm going to factor out a GCF. 8 and 6, I can't divide those both by 6, so I have to think lower. So I know that the GCF, the number is 2, and then they both have an x term. So I can factor out a 2x. 8 divided by 2 is 4. X squared divided by x is x. 6 divided by 2, that's a minus 3. X divided by x is 1. Now that it's totally factored, I can set each factor equal to 0 and solve for x. So 2x equals 0, and 4x minus 3 equals 0. Now I just solve for x. This is being multiplied, so to undo multiplication, we divide both sides by 2 to get x equals 0. Now this one, there's a little bit more extra steps here. It's okay. We're going to get through it. We're going to first move over the 3 by adding 3 to both sides. We get 4x equals 3. Still need to get x by itself, so we're going to divide both sides by 4. And I get x is equal to 3/4. And that's it. Those are my two solutions, 0 and 3/4. Those are my 2 points where the quadratic crosses the x-axis. Okay, last 2, and then we're done. Number 7, 3x squared plus 9x minus 12 equals 0. Is it already set equal to 0? And the answer is yes. So now we can just start by factoring. Now, this seems like it's going to be more of a challenging one. It's actually not. What do you notice the 3 and the 9 and the 12 all have in common? Well, they have a 3. We can actually factor out a GCF first to help us here. So if I factor out 3, I'd be left with x squared plus 3x minus 4 equals 0. And now I can factor the inside further, just like I did on 3 and 4. So I'm thinking, okay, what two numbers multiply together to get me negative 4 and add to get me 3? That's going to be positive 4 and negative 1. Now that I've factored out that GCF, I can actually still use the shortcut. So it's going to be x plus 4 times x minus 1. So all I did on my first step, all I did there was factor out a GCF. And then I continued factoring. There we go. Okay, so now I can set all factors equal to 0. Now, some of these are going to be a little weird. We're just going to go with it right now. So we have 3 equals 0. We have x plus 4 equals 0. And we have x minus 1 equals 0. Now, 3 equals 0, there's not a variable. So that one actually doesn't even matter to us. We don't care about it, and I'm just going to cross it out. What does matter to me is this x plus 4 and this x minus 1. So I factor out, or I move over the 4, and I have x is equal to negative 4. I add the 1, and I have x is equal to 1. And so I have still two solutions. This one, remember, doesn't matter. It's unimportant. And so this is going to be as ordered pairs, negative 4, 0, 1, 0. So either way you guys write it, ordered pairs or list them, it's totally fine. I really don't care which way you guys write it. Okay, last problem. So what I want you guys to do, 8 is really similar to 7. What I want you guys to do is pause me here, try 8 on your own, do the best you can, and then come back and check your work. Okay, so you should be checking your work. First thing we're going to do is the equation set equal to 0, and the answer is yes, it is. So then we're going to factor. Just like number 7, I first noticed that there's a GCF that I can factor out of the trinomial. I factored out a 5. It left me with x squared minus 4x minus 12. And then I'm going to keep factoring the inside. So I factored the inside. What two numbers multiply together to get me negative 12 and add to get me negative 4, negative 6, and positive 2. Now that it's fully factored, I can set each factor equal to 0. So now that each factor is set equal to 0, well, this one's weird, right? 5 equals 0. There's no variable. There's no x to solve for. We don't care about it. We care just about these two. So now I'm just going to focus on solving these two for x. And I solved them both for x. So now that I've got x by itself, again, doesn't matter how you write them, ordered pairs, x equals whatever you want to do. So as an ordered pair, it would be 6, 0, negative 2, 0. Now, just to kind of bring it all back together, remember, this is showing you the 2 points where the graph is going to cross the x-axis. So if I were to graph this one, 5x squared minus 20x minus 60. Oh, there we go. I have my two solutions. I can look to see, where does it cross? It crosses at negative 2, just like we got, and it crosses at 6. And so my parabola, this is terrible. Okay. The parabola has a vertex super, super low, and then we can see the solutions. It crosses the x-axis at those 2 points, just like we found. Okay, so that's it for solving by factoring. That's all we're going to do for this section. If you guys have any questions, need any help, please come to office hours. Email me. We can always get on a Google Hangout separately. Totally fine. Hope you guys have a great day, and I will see you soon. Bye, guys.